Just make it to be a little. Treat it like an animal, David. It makes it worse if after someone playing you don't see anybody else.
You know,
And you're yelling, you don't see I'm not comfortable. No, you can't so much. You can't be bullied if half in your mouth. Wait, half more survival. Half in your mouth. So like I don't see anyone. So I found my friends.
Running out of help, space before I run into sad stuff. It's like 15 pages long.
I don't think that's good.
No?
I mean, for today, yeah.
I mean, like, in general.
No.
Do you record yourself?
They're double-sided too, so like both sides, so it'd be like 30 together.
Here's the title for you. So we're going to do the same problem a couple different ways. Sneeze? How do you rupture something? Okay. So there's two ways we can do these. Kind of like before, you can either use u-substitution or you could choose not to. But I'm going to go through both ways. There's advantages and disadvantages to both. Let's just kind of start going. So if I go without using u-substitution, I'm just going to talk through like, okay, this is the big guy. This will be my little guy. What's the derivative of the little guy? 2. So we're all set. What's going to happen to the derivative of the little guy? It's going to disappear. My job would be to integrate the big guy. Leave the little guy alone. I got my 0 and my 1. I don't need the plus c in definite integrals because when I plug in both those spots, I'm going to put the c minus c. So, if I'm doing this, now I'm going, okay, 1/4 times 2 plus 1 to the 4th power minus 1/4 times 0 plus 1 to the 4th power. You guys with me? What is 3 to the 4th power? 81, so that'd be like 81/4, right? Minus, this would be 1/4, so that would be 80/4, or what we like to call 20. That's a totally valid way to do it. I did not use u-substitution, just kind of worked around it. But you do want to know the u-substitution way because they'll ask you some things that force you to know that form. Yeah. 2. It disappeared because the derivative of the little guy disappears. So, for example, like if I started here and took the derivative, that 2 would kind of like appear out of nowhere, right? I'd multiply by that 2. So I'm going, you with me? All right. You guys okay back there? I'll talk to you. Are you okay?
Yeah.
Okay. Do you have it all straightened out?
Yeah.
Okay. What?
This was longer than it needed to be.
He's had some caffeine, so he's not.
Maybe we just go on.
Second way is use u-substitution. So what would u be in this case? U would be the 2x plus 1 that would make du equal to 2 times dx. And that's what I have, right? So it's all squared away. I don't need to like multiply it by a constant or anything. But when you go to rewrite this, so we're going to put all of the stuff inside of the integral. It's going to be u's. It's not going to be x anymore, right? So I'll have, on the inside, I'll have u to the third times du. Agree? I need you to agree with me.
Yeah, 1 is a 0.
I agree.
You don't put the 1 and the 0. That's the point, and that's where I'm headed. So these are u's. These are x's. You can't mix u's and x's. So you have to turn these into u's if you're going to do it this way. This right here is how we do it. I know that u equals 2 times the x value plus 1. Well, the x value up top is 1. So what's the u value up top? 3. So you're taking that x value, you're plugging it in here, because we're switching the whole problem into u's. That's what u-substitution is. We take the x's and we move all the u's, we do the problem, and then in an indefinite integral we got to put it back. But in a definite integral we don't. It actually gets easier at the end. So all I'm doing there is saying, well, these are in terms of x. This whole problem is all x's. I don't want x anymore, I want u's. So I can't put an x value into a u equation. So I take the x value, plug it in here, and figure out what the new u is. What's the new u going to be on the bottom? 1. So 2 times 0 plus 1 is 1. Integrate this, 1/4 u to the 4th, and plug in. So I don't have to go back to the x's. There's no reason to. So I've made the advantage to this way is this part is short. It's easier. Like it's just less messy than all this stuff, right? The disadvantage is you have to put it into u's, but it's not that big a deal. And then I just plug in. So 1/4 times 3 to the 4th minus 1/4 times 1 to the 4th. Which is exactly the same stuff we ended up doing over here. It just took like an extra step to get there, kind of. And I'd end up with the same thing. So it's 80 over 4. Or it's 20. And I want you to know both of those processes. I want you to be able to do both of those. Questions on either one of those? Yes.
Why would you want to do u-substitution? It looks like it gives you more chance to mess up. So you gotta like correctly plug in the x values to make them u values, and you gotta make sure you do the u-substitution correctly, and then hope you.
So the advantage to one is they're gonna ask you questions in the AP test that involve the u process at some point, so you're gonna kind of have to know it for that reason. But the advantage of like the overall, why they would do that, plug it into this, not necessarily in this problem, but in like more difficult problems, plugging into the u's is easier than plugging into all the x's.
Okay.
So if I had like, over here it might say like cosine of u, and over here it might say like cosine of 2 pi plus e to the x. And you know, that's a lot easier to work with than this.
Okay.
You with me?
Oh,
What?
sorry, I was having a hard time reading.
In both, you still have to plug.
I couldn't figure out that was a cosine. It looked like it had to be
You do have to plug the value in both, but like in this case, I think it's easier to do 3 to the 4th divided by 4 than it is to do.
Yeah.
I mean, it's not like a huge difference here, but
That's,
you know.
yeah.
Other questions? Okay. Let's say cosecant. Don't write this down, dude. I'm making this up as I go. I'm not sure it's going to work well. We'll see. We're not. No. Forget that. If I want problems with trig, I'm going to pull them for the AP test. I'm writing those. Are you talking about the calculus?
Yeah, you're on Thursday, so you just ask.
So, Alex is.
All of the races.
When are the All-Stars meeting?
So like,
When you plug in, no, it's always plugging in the top number minus plugging in the bottom number. You didn't watch my video? Yeah, don't forget your con is due tonight. Yeah.
so like, you have something with an exponent down there. Just squares.
So you bring that on top, make two things.
So negative. Oh, that's what I'm saying. So just turn to exponent. It is there.
Alright, so if I rewrite it, I'm going to do that first up here. That'll be 4 times x plus 1 to the negative half. So that's to the 1/2, it's square rooted, bringing it up. That's what you're talking about right here. So negative 1/2. And then if I'm doing like the regular way, I don't know what regular is, but I guess the non-u-substitution way. Then, what's the derivative of the inside? 1. You have a 4 then. So we're going to put a 1/4 on the inside and a 4 on the outside, meaning that'll go away. Then I integrate the big guy. So I add 1 to the power, multiply by the reciprocal of the new power, which is 2 times the 4 that was out there. So I end up there. Then I'm going to start plugging in. So I'm plugging in the top number, 8 times 3 plus 1 to the 1/2 minus plug in the bottom number. So 4 to the 1/2 is 2 times 8 is 16. 1 to the 1/2 is 1 times 8 is 8. Did you guys get 8?
Yep.
Alright. So if I run through that the u-substitution way, I would say u equals x plus 1. du equals 1 times dx. But I need it to be 4 times dx. So I have to multiply this side of the equation by 4 to make that happen, right? But then I better multiply this side also. So now I would have, so instead of 4 times dx, I'm going to put 4 times du. So I have 4 times u to the 1/2 times du. And I can't just put the 0 and the 3 there, because these go with the x's. I need them to be in terms of u. I need everything in this to be in terms of u. So I'm just plugging in here. So u equals x plus 1, and x is 3. So u is 3 plus 1, or 4. In terms of x, this lower limit is 0. But in terms of u's, it's got to be 0 plus 1 equals u. So that'd be a 1. Add 1 to the power. So it's u to the 3/2, multiply by the reciprocal, so 2/3. So that's 8/3. Oh, it's negative 1/2. But yeah, something felt wrong there. Negative. This is negative 1/2. Okay, add 1 to the power, so u to the 1/2, multiply by the reciprocal, so now we get 8. That makes more sense. So then 8 times 4 to the 1/2 minus 8 times 1 to the 1/2, and we end up with the same thing, so it's going to be 16 minus 8, which is 8. How many got to the correct answer both ways? Cool. Questions I can help with, Kyle?
Well, 4's come from.
All the 4s.
Every single 4 on the
Which? U-substitution or not U-substitution?
I thought you got rid of the 4.
Okay, so in this one, you do U-substitution, don't you?
I did both of them.
But in general, are you a U-substitution person? So that 4 came from the fact that this derivative is supposed to be a 1. Yeah, it's supposed to be a 1. But instead it's a 4, so I have to make that adjustment. Was that a legit oh yeah, or are we pretending?
Yeah,
So over here,
I thought the number didn't matter.
it's not that the number in front doesn't matter, it's that the derivative of the little guy disappears. So when we have, like if I ask you to take the derivative, please, right, of f of g of x, you would tell me that it was take the derivative of the big guy, leave the little guy alone, multiply by the derivative of the little guy. Right? Well, we're going backwards now. So when I integrate the big guy, so f prime goes to f, I leave the little guy alone, and then the derivative of the little guy just goes away. So that's what you're thinking of. As soon as I get this set up to be the derivative of the little guy, it vanishes. I don't know if that I come over and like look more at what you want if you want. Does that help or not really?
Yeah.
I think you know what I mean because you've done it a ton of times. I think you're just not picking up the spot for whatever reason. We can look at it. Yeah.
So like with the whole like 3 and 0 at the top,
Yeah.
and you were plugging that into U to get the 4 and the 1.
Yeah.
What if theoretically when you plugged it into the U, the one on the top was less than the one on the bottom?
Then you just do it. That could happen, and you do the exact same process.
Okay.
So it could come out where this is a 10 and this is a 4. You would still plug in the 4 first minus the 10. That could happen.
So you can get a negative number right as an answer.
Yeah, that wouldn't necessarily give you a negative number. Because if your answer was negative and then I go backwards, it's positive. Does that make sense? But yes, you can get a negative number. What does a negative number mean if I get a negative answer in these problems? Or below the axis, right? Should we do more? Do the first one on the worksheet. And then I'll do it too, and we can compare, make sure we're good. I would like you to do the first one both ways, and the second one. That's why I left you all that room. And then like 3 through the end, you can kind of do whatever you want to do. But you'll notice I left you tons of room on the first one. What do you mean checking? Right? Yes. I don't know. I ain't new to this whole homework thing, but I check it if I want, I don't if I don't want.
Okay.
That's how it goes. That happens, that's really the thing you just asked about happens in the first one. I think.
false gates because they're negative ones.
What do you mean?
For power, because the power's negative 1.
What are you talking about? What about number 1?
That thing almost happens where one is bigger than the other.
It does happen, doesn't it?
No, because the power's negative 1, so it makes it where it's actually less.
The power has nothing to do with these two numbers, though.
Oh, okay. Never mind.
Did anybody do the substitution way yet?
Slowly.
Did you get 12 on the bottom and 6 on top?
Yeah.
Yeah, okay.
See, I didn't do it the u-substitution way, so it's a little different.
Well, then why are you commenting on the u-substitution
I
way?
didn't know you were doing the u-substitution way.
There's the u-sub, like that old process worked out. I'll talk through like the reverse chain rule way. It's just seeing the work for that doesn't really do too much for you. Did I get the answer right?
Yes.
Is it what you thought?
Yes, it is.
Thank you.
I think it's weird because of the definite ones. I can't do the u-sub, but with these I can only do the u-sub.
Oh, there's a negative.
That is weird.
Oh, that would totally explain.
That makes like no sense at all.
Well, because I don't like doing the indefinite ones like this.
It's shorter.
Yeah, but this.
But this, I think it's, yeah, that's cool. I guess that's not that weird. I kind of, I prefer, yeah, I prefer that. What's nice?
Oh, there's a negative. Oh, duh. Hey, I missed 2 negatives.
That should have canceled out and made you okay then.
No, there was a negative in the exponent. And negative. Yeah.
Not
I
like,
totally was getting into the thousands. Not
you had like 12 to the second, or like,
yeah, I did 12 to the third.
that's a,
Yeah.
oh, because you had a positive 2. So
Yeah, positive 2 and then I added 1. Yeah.
Will I ever need to use the normal one, or can I just use u-sub for all?
you can use u-sub all the time. Are you squared away then? Do you think you understand the question?
I understand these.
You do. You just get it in a different way. If that makes sense. I mean, it's just like if I said, what's 10 plus 10, and you were like, I think about it as 10 times 2, is that okay? Like, yeah, that's the exact same thing.
That makes sense.
So if I were to talk through the top one, and if you're already got it right, you keep going. I'm just doing it for anyone that needs it. I would say, okay, this is the little guy, the derivative is supposed to be 4x. It's not. I would need to multiply it by negative 1/3 to make that happen. So I multiply the outside by negative 3, and then that's going to disappear. And then I'm going to add 1 to the power. Divide by the new power, so I get 3. Then you're going to plug in 1 and negative 2. So the downside of not using u-substitution is this part right here, because the plugging in is just a little bit more work. How many got 1/4 or 3/12 both ways, and you feel like you're king of the world right now? All right. Questions I can help with on either of the ways? And so I would say, like Kyle said, if I only know u-substitution, is that okay? Yes. But the other way around, I don't agree with. If you only know the not u-substitution, that I'm not a big fan of, because that could cause some problems. Questions? Thoughts? Concerns? Comments? Smart-ass remarks?
Oh, you know I'm the king of
Anything?
that.
Alright, keep going. So the same as anything else, that's your homework. I would say that if I checked your homework to consider it done, I would need to see the whole thing. There's not that many. But you don't need to do them all both ways. Just gotta do one. I would prefer you do number 2 both ways. And then after that, you pick whichever way you want. I'm not going to make you do it. That's fine. How many are preferring u-substitution with this? How many prefer the not? So that's not very many then, really. Okay. You do a different way? It is different.
A new spicy way of doing calculus.
Not really, by the way.
The pile technique?
Pile technique.
He created
Diaz technique is the calculator. I don't know what the pile technique is.
He created it all last night. It's his whole new theorem.
He has what this
Do you know how to do it with it?
No, I'm just using it to fucking use it.
You can do it on yours. I'm pretty sure.
The 89 is really great. The 89 is will do everything to do with stuff. That's why we haven't used it yet.
I gotta find those.
What?
What's the point of an AP test?
Because you only get the calculator on half the AP
No,
test.
no, but like when you go into like the real world,
The half that you do.
you're gonna have a calculator. So like, what's the point? That basically describes education.
So you learn like what is the power of the concept. Otherwise you're just learning like calculator.
Yeah. I mean, that's pretty much everything we've ever done in our lives.
Yeah, I mean,
Yeah, I love when
learn
people
addition
are like,
first grade.
Well, like it depends on what you go into.
yeah.
I gotta bring you the poster of like why calculus is important. Because there is an explanation. It's like it's not important because you're never gonna use it. It's important because you're learning how to problem solve.
You're on the same side.
It's important.
That's like one of the biggest things in policy.
Can you
So people would be like,
Be verbal about it.
when am I ever going to use calculus? And like, they're sitting there reading like To Kill a Mockingbird. Like, what are you going to use To Kill a Mockingbird? Like, it's all pointless. Like, it's all just learning to learn, learning the process, learning to problem solve, and playing the game. I mean, you guys know that. You got to jump through the hoops to get where you want to go.
Exactly.
Yeah.
Except
Like when I talk to engineers, they don't really use the calculus as the computers do it all, like you said. But you have to know the concepts. You have to know what you're working with, what it means.
That way the computer does just like really
You wouldn't be able to tell otherwise. Yeah.
This bridge isn't going to
Right. Right. Instead of just like, well, the calculator said, you know.
it says 142.
Is that like
There.
so like that is
So it could be that it's all above the axis, just like a tiny bit, or it could be some is below, some above, some is above. But there's that much more above.
how so it could be like that, but then there's one area above more. So let's say those two parts are equal. So then that one equals one.
No, you wouldn't go through that exact. You always, so. Probably, this region and this region is canceled.
It's the one. Okay.
Or it's like a, I don't know, or it's like really skinny above the x-axis. Just like that all. Not that you want to see.
It's too much work.
Okay.
I was just curious if it was, but I was gonna say I didn't think it was like a line. It's
It's very. Or if that was like meters per second, we just found meters